Hello student, I am Dr.A.K. Sinha, Professor of Chemistry. Today I am going to discuss quantitative analysis of organic compounds. Last class I have started and I finished estimation of carbon, hydrogen and nitrogen. Estimation of carbon, hydrogen and nitrogen. Nitrogen by two methods, means Dumas method and Geldahl's method. I have discussed in details. Now I am going to discuss rest of other elements, estimation. And now I am going to discuss halogens. Halogens, estimation of halogens or determination of halogen. It is done by Cartius method, Carius method, Carius, Carius method. Question is asked. How we will estimate halogen by this method, means Carius method? A known mass of an organic compound is heated with fuming nitric acid in the presence of silver nitrate. Actually reaction is simple. Already I have discussed during the test, qualitative analysis. In estimation generally test reaction will be the same what we have discussed in the qualitative analysis. Here I am telling you, in Carius method, a known mass of an organic compound is heated with fuming nitric acid in the presence of silver nitrate contained in a hard glass tube. That tube is actually known as Carius tube. That tube in which you will take fumic nitric acid in presence of silver nitrate, that hard tube is known as Carius tube. I will try to send this tube. Carbon and hydrogen, already we know that carbon and hydrogen present in the compound are oxidized in carbon dioxide and water. After that, what will you do? Carbon, hydrogen, that already I have discussed, you are knowing. Then after this, carbon will convert to carbon dioxide and hydrogen will convert to H2O, means water, oxides of hydrogen. After that, what will you do? The halogen present, suppose organic compound has halogen, means maybe fluorine, chlorine, bromine, iodine. The halogen present forms the corresponding silver halide. If because treatment you are doing with silver nitrate, then silver nitrate and any halogen, you know that it will form AgX. X means maybe chloride, bromide, iodide, silver chloride, silver bromide, silver iodide, like this way it will form. The now main thing is calculation. How will you calculate? Then now suppose AgX formed. Then now first you consider compound taken is equal to m gram, a small m gram, and mass of AgX formed, AgX capital X, mass of AgX formed, that is equal to m1 gram. M gram is the compound and m1 gram is the mass of AgX. After that, calculation will start. 1 mole of AgX means molecular mass you have to calculate. Then 1 mole of AgX contains 1 mole of X in the form of ion, maybe fluoride, chloride, bromide, iodide. Then 1 mole of AgX contains 1 mole of X. Then mass of hydrogen, mass of halogen in m1 gram of AgX. How much that you have to calculate? Very easy. That is the AgX. AgX, molecular mass of AgX contains X gram. X gram, this thing. AgX contains X means chloride, bromide, iodide, whatever be. Then mass of halogen in m1 gram of AgX is equal to what? Very easy. Atomic mass of X divided by molecular mass of AgX. In AgX, suppose X gram of this things, X not, this things, AgX. Then AgX has X. AgX has X maybe chloride, bromide, iodide. Then that molecular mass you will calculate. Then molecular mass that will be for Ag, it is 108, silver. Atomic mass is 108, remember it. Silver atomic mass is 108 and Cl 35.5. Then you add it both, 35 plus 108, then 143.8. Then like that way molecular mass you can calculate of silver chloride. Anyone you can take as example, silver chloride. Then 108 plus 35.5. Then 35 and 8. How much? 43. Then 143.5 gram contains 35.5 gram chloride. As for example, I am telling you, 143.5 gram silver chloride contains 35.5 gram chloride. Then 1 gram how much? 35.5 divided by 143.5. Correct? Then M1 gram. Correct? Now mass, this mass of AgX was, you suppose you have taken M1 gram. Then M1 that will go upside, means 35.5 divided by 143.5 into M1. M1 is the mass of silver chloride or AgX, you can tell in general. This is a simple formula to calculate this mass of X. Mass of X or mass of chloride, because chloride is in the form of AgX or AgCl. That's why AgCl mass, how much formed you are knowing, M1 gram. Then the starting point is that when AgX has X, then 1, and then for M1. Very simple way. Then AgX, as for example, silver chloride, I told you 143.5 gram contains 35.5 gram chloride. Then 35.5 divided by 143.5, then M1 will multiply, just it will go up. Then 35.5 into M1 divided by 143.5. But in the term of formula, you can write atomic mass of X divided by molecular mass of AgX and upside M1. This is the mass of halogen in M1 gram of AgX. Now, if you want to convert it into the percentage, then very easily you can convert. Already I have told you that now you are knowing the mass of halogen. Mass of halogen you are knowing, suppose it is the Y gram. Now you have calculated Y gram, suppose. Then now compound taken was M gram. Compound taken was M gram. Then M gram gives Y gram of you can say halide. Y gram of halide. Then M gram gives Y gram halide. Then 1 gram Y upon M. Then 100 gram. How much? You have to multiply upside. Means Y into 100 divided by M, mass of compound. Then now you put the value of Y. Then Y already calculated, atomic mass of X into M1 divided by molecular mass of AgX, that is equal to Y. Then now in percentage you put the value of Y, then you will get all thing is the same. What you calculated mass of halogen, extra things will be upside 100 and down M. M means compound, mass of compound taken, organic compound. Means formula I will get percentage of halogen is equal to atomic mass of X into M1 into 100 divided by molecular mass of AgX into M. Correct? Then this I have told you, determination or estimation of halogen. One question is there, problem. Okay, how will you solve? Only just it is very simple way, only they have given the value, same things, you have to put the value in the formula, you will get the result. Question I am reading. In Carius method of estimation of halogen, 0.15 gram of organic compound gave 0.12 gram of silver bromide. Find out the percentage of bromine in the compound. Then now here important thing is that you have to know the atomic mass of silver and bromine. Only then you can calculate. Without this you can't calculate. Hence you remember it. Chlorine you know, that is I already told you 35.5. Then for bromine, what is the atomic mass of bromine? You remember 80. And silver how much? 108. Then now you add both. Then 188. Then 188 gram silver bromide contains 80 gram bromine. 80 gram bromide ion. 188 gram silver bromide contains 88 gram bromide ion. Then easily you can calculate. Then 1 gram how much? 80 divided by 188. Then for given value is, what was the weight of these things? Silver bromide. Then its weight is given 0.12. 0.12 gram silver bromide. Then starting point is 188 molecular mass of silver bromide. 188 gram silver bromide contains 80 gram bromide ion. Then 1 gram 80 divided by 188. Then 0.12 gram. How much? Just you simply multiply upside. Then you will get 80 into 0.12 divided by 188. Then now you are getting the amount of bromine. amount of bromide ion. Now you got, okay. Then now you are knowing the these things, amount of this you got the 0.12 gram silver bromide contains, I told you, 80 into 0.12 divided by 188 gram bromine. This is the mass of bromine or bromide ion. Now percentage you have to calculate. Very easy. Then mass of compound is given 0.15 gram of organic compound. Then 0.15 gram organic compound contains, now suppose it is the Z gram, suppose it is the bromine mass Z. Then easily you can calculate that 0.15 gram of organic compound gives Z gram of bromine. Then 1 gram how much? Then 100 gram how much? Very easy. Means you can write that is the Z into 100 divided by 0.15. Z into 100. Z into 100 divided by 0.15. Now you put the value of Z here. Then Z is equal to, already know, 80 into 0.12 divided by 188. Then finally percentage of bromine, after putting the value we will get this Z value 80 into 0.12 and down it is 188. Now extra things, 100 you have written up, and down 0.15. That is the mass of organic compound. After solving this, you will get 34.04%. 34.04%. Hence, percentage of bromine will be 34.04%. This I have told you about the halogen. Now come to the sulfur. Actually everywhere you have to consider the organic compound. Then first to find out the amount of these things, amount of the element. Now in this case sulfur, previous case chloride, previous case halide you have considered, maybe fluoride, chloride, bromide, iodide, anything that you have to consider. First step that amount of element you have to calculate, and second step percentage. Then in percentage you require quantity of organic compound taken, and then you convert it to the 100. Two step. Then here also sulfur, in case of sulfur you will tell a known mass of organic compound. A known mass of organic compound is heated in a, where you heat? Then carrier tube, what I discussed for halogen. Here also carrier tube with sodium peroxide. There you have taken silver nitrate, but here you are taking sodium peroxide or fuming nitric acid. Sulfur present in the compound is oxidized to sulfuric acid. Here because sulfur is present in the compound and peroxide is there, means oxygen is there, sodium peroxide Na2O2. Then after the reaction it will be oxidized to, sulfur will oxidize to sulfuric acid, means H2SO4. It is precipitated as barium sulfate. It will precipitate as barium sulfate by adding excess of barium chloride. Means here three reagent you are using. First that is a compound you will take, first things, plus sodium peroxide. And third things, what you are using? Barium sulfate. Then finally sulfur will convert to the barium sulfate. Barium chloride you have taken, barium chloride, and sulfate was there. Sulfuric acid means H2SO4. SO4 is SO4 2 minus. That is a sulfate, and the barium is a Ba plus. Ba plus plus 2 plus 2 minus. It will neutralize barium sulfate. It will form precipitate. You can filter it. All are soluble. Only barium sulfate is solid. It will settle down. Then you can filter it. Means barium sulfate you got from barium chloride. Correct? In solution H2SO4 formed. Then H2SO4 plus barium chloride. It will form barium sulfate plus HCl. Then HCl is just soluble. Only barium sulfate is not soluble. Insoluble. It will settle down as a precipitate. You can filter it. Barium sulfate. After that, calculation is there. Okay. If you just the precipitate is filtered, washed. 3 steps generally it is done. In all quantitative analysis, if you will get the precipitate, then 3 steps you have to do, because that will be wet. Then first you have to just take the weight, how much it is there. Then you have to take the weight, means you weigh it, how many gram is there, because you require this amount is required, and then you weigh it, and after that wash it. How will you wash? Then by suitable, generally water, it is washed with water or sometimes acid, so that all soluble things, impurities will dissolve in water. Or if acid in that, if any impurities, then you will get pure compound, barium sulfate, you will get pure. Impurities dissolved and went outside in water or acid. Only pure barium sulfate you will get. Then now it is wet. Then now you have to dry it, because otherwise directly you can't consider this is the only wet, because in that some water is absorbed. Hence you dry it, and after drying, what is the weight, that you note down. That is the barium sulfate weight, correct weight, dry condition. Actually in desiccator you can use this. How will you dry it? Then in desiccator calcium chloride will be there, anhydrous calcium chloride. Desiccator is one instrument. It will be covered. Air can't enter inside. Then inside calcium chloride will be there, dry calcium, anhydrous calcium chloride. Then it will absorb the moisture. Of the barium sulfate. In barium sulfate, whatever moisture was there, water, that calcium chloride will, anhydrous calcium chloride will absorb. Now it will be dry. Then that dry barium sulfate, you just take the weight, correct barium sulfate. No water is there, otherwise error will be there. Then after that, simple calculation, what I have discussed in case of every time, just now today I discussed in case of silver halide, same calculation is there. Let the mass of organic compound taken is equal to m gram, a small m gram, and mass of the barium sulfate formed, that is the m1 gram. Means after drying you have taken again weight. Final weight only you can one should take, not in the beginning. After drying you should take only one time weight, m1 gram. Suppose it is a m1 gram. Then now you know what I am going to do, you are knowing. Then m1 gram. After that, how will you calculate? Here again same way, barium sulfate. Then 1 mole of barium sulfate, that is a 233 gram of barium sulfate. Okay. Then here total molecular mass of barium sulfate is 233 gram. You can get it by adding atomic mass of barium plus atomic mass of sulfur plus this SO4, then atomic mass of oxygen into 4 because O4 is there. Then barium, atomic mass of barium plus atomic mass of sulfur plus atomic mass of total mass of oxygen, means 4 into O. Atomic mass of oxygen, you add it, it will come 233 gram barium sulfate. Then this barium sulfate contains 32 gram sulfur. Then very easily you can calculate, you can say either direct sulfur you can calculate. Why will you calculate sulfur? Direct sulfate, as you are knowing, 32 gram barium sulfate contains 32 gram sulfur. Then 1 gram barium sulfate, how much it will have sulfur? Then 32 divided by 233. Then M1 gram barium sulfate was there. Then that M1 gram, how much it will have? Experimentally you have done M1 gram barium sulfate. Then the 233 gram barium sulfate contains 32 gram sulfur. Then 1 gram barium sulfate, how much? 32 divided by 233. Then M1 gram barium sulfate, how much? Into M1, means 32 into M1 divided by 233. Then now this you are knowing the you have calculated the this sulfur you have calculated. Suppose now it is the Z gram. Then percentage now you have to calculate. Then percentage, how much you have taken the organic compound? Organic compound was M gram. Then M gram given Z gram barium sulfur. M gram compound given Z gram sulfur. Then 1 gram Z by M. Then 100 gram, it will go upside into 100. Then now you put the value of Z. Then Z is equal to 32 into M1 divided by 233. Means finally you will write 32 into M1 into 100 divided by 233 into M. M is down. M is the mass of compound. Then this is the formula, that 32 into M1 into 100 divided by 233 into M. Then only if you are knowing the value of M1 and M, then easily you can calculate the percentage of sulfur. Now one numerical I am telling you. Okay, this type of numericals may be asked in examination. Then I am telling you, easily you can solve it. I think only you have to put the value of M1 and M2. M1 and M value. Question I am reading. In sulfur estimation, 0.157 gram of an organic compound gave 0.4813 gram of barium sulfate. Okay. What is the percentage of sulfur in the compound? Then it is very easy to calculate. Same things you have calculated now, only value of M and M1 value you have to put in the above formula. But here again you have to calculate molecular mass of barium sulfate. Then here easily can calculate barium atomic mass of barium plus atomic mass of sulfur plus atomic mass of oxygen into 4. 4 O4 is there. 4 into oxygen. 4 into O. Then here barium is equal to, atomic mass of barium is 137. Always remember, barium atomic mass is 137 and sulfur is 32 and oxygen is how much? 16. Then 16 into 4, 64 oxygen. Okay, plus 32 sulfur plus barium 137, total 233. Then now 233 gram barium sulfate contains 32 gram sulfur. Then 1 gram barium sulfate, 32 by 132. Then in question they have given barium sulfate weight, it given 0.157. Okay, that sulfur, this weight is barium sulfate weight is given 0.17 gram. No, this is organic compound weight. This they have given 0.4813 gram barium sulfate. In question, 0.4813 gram of barium sulfate given. Then you have calculated barium 233 gram barium sulfate contains 32 gram sulfate, then 1 gram 32 by 233, then given weight is 0.4813. You multiply upside. Correct? Then you got Z, weight of sulfur. Now in formula you put these things, 100 divided by M is there. Then M, that is M, that M is given 0.157 organic compound mass. M value is given 0.17. And now this, then in percentage I am taking you, Z already calculated. Then in percentage, Z into 100 divided by M. Z into 100 divided by M means compound, organic compound. Correct? Because M is the organic compound. M gram organic compound gives Z gram sulfur. Then 1 gram how much? Z divided by M, small m. Then 100, it will go, 100 will go up. Then Z value is 32 into M1 divided by 33. Hence total you will get, after putting the value, you will get 32 into 0.4813 into 100, and down you will get 233 into 0.157. 0.157 is the mass of organic compound. Always it will be down only. Then after solving, you will get final result 42.10%. 42.1% or 42.10%. This is the final answer. Then it is a easy. This type of question is asked actually. Okay, is a straightforward, and this only in that this question they may make you can say some complicated by just question they will make long. They will give a little more distance. Direct now they have given direct mass of organic compound, that will give directly. This you calculated not, they have given mass of barium sulfate. Then mass of barium sulfate directly they will not give. They will give in indirect way. In indirect way they will give in such a way that you have to do their initial weight, final weight, and then after that what is coming difference, that will be the mass of barium sulfate. Means they will try to make it long for IIT advance or in medical. They will not give directly anything. They will make little complicated. Directly barium sulfate, as for example, they will not give. They will give initially its weight was there, porcelain weight, and after that its weight was this, like that way. Then you have to understand the question and just do minus, final minus initial. Then that is the weight. Like that way, they will they will try to make it complicated, or also they can write sometimes that room temperature was this, pressure was this. That is not required here. But because experiment has been done, then that time temperature, what was the temperature they can give, what was the pressure that they can give, only to confuse the student. Okay, that is not required here. But because experiment was done, that's why they will write all the things. Then it should not get confused. Direct, what I told you, we have to do. Then now I am going that to discuss phosphorus, estimation of phosphorus. A known mass of an organic compound, always known mass you have to take. Okay, it's same step. Okay, that we have to not, are not going to change. Steps are same. Only you get the value, you have to think. A known mass of an organic compound is heated with fuming nitric acid. After that, what will happen? Whereupon phosphorus present in the compound is oxidized to phosphoric acid. This will differ always. Then phosphoric acid you will get H3PO4. How you will get? Then compound plus fuming nitric acid. You have to heat it. Then it will be oxidized. Phosphorus present in compound will oxidize and it will give phosphoric acid, H3PO4. And it is precipitated as, again, ammonia if you will treat, then it will, this phosphorus you have done test, that is the ammonium molybdate test. That generally 99.9% only whenever phosphorus name you will take, then you should be alert that okay, ammonium phosphomolybdate you have to use, or ammonium molybdate test is there. Okay, that formula you have to remember, all the reaction details. That is very, very important. That is the long, all things are long. Molecular formula is long, and balanced equation is long because it requires balanced equation also. Okay, but it should not be, it will take 1-2 minute extra time, but you can calculate very correct answer you will get, or because it is a fixed direct molecular mass you will be knowing, and so no problem will come. Then now this you got the phosphoric acid, and it is precipitated as ammonium phosphomolybdate. This formula always you remember. It is in two parts, ammonium phosphomolybdate. Then ammonium formula you have to write, phospho formula you have to write, molybdate formula you have to write. 3 formula it will include. Then its formula will be NH4 whole 3. H3PO4 is there. Then in the place of NH3, NH4 has come, ammonium. H gone, 3H gone. In the place of that, 3NH4 has come. That's why NH4 whole 3. You have to write NH4 whole 3. And this phosphate is PO4 3 minus. PO4 3 minus. Then there that 3 NH4 came. NH4 plus, NH4 plus, NH4 plus. 3 plus was there. And phosphate has 3 minus. That's why it became NH4 whole 3. NH4 whole 3. NH4 whole 3. This NH4 whole 3. You got PO4. And after that, already told you, third part, phosphate you have written, ammonium you have written. Then third part, that is the 12 molybdenum O3, MoO3, MO means only molybdenum, O3, then 12 you have to remember, 12 MO3. Then this you got, ammonium phosphomolybdate, you will get phosphoric acid precipitated in the form of ammonium phosphomolybdate. By adding ammonia, you will get only when you will add ammonia and ammonium molybdate, you will add in phosphoric acid, then you will get this, correct? Phosphoric acid plus ammonia plus ammonium molybdate, then you will get ammonium phosphomolybdate, correct? This is the one method. You got the ammonium phosphomolybdate. Second method I am telling you, that also it will be used. This is another method. Here what you have to do, alternatively, I am telling alternate method, alternatively phosphoric acid, what you got, may be precipitated as magnesium ammonium phosphate. Another method. Phosphoric acid may be precipitated as magnesium ammonium phosphate by adding magnesia mixture, means magnesium hydroxide, which on ignition yields Mg2P2O7. How will you get this? Magnesium ammonium phosphate, how will you get? Then you will get phosphoric acid, you got that, it will have to add magnesia mixture, magnesium hydroxide, you have to do treatment. Then an ammonia will be also. Then you will get Mg2P2O7. You can note down if you have pen, pencil, paper. Always you keep Mg2P2O7. This you have to ignite it after mixing. Then you will get Mg2P2O7. Then from this Mg2P2O7, again you can calculate direct P, you can calculate. P2 is there, na? Then molecular mass you calculate. All things you are knowing. Magnesium you are knowing. Magnesium 12, phosphorus 31, oxygen 16. All you know. And molecular mass you are knowing in P2. Then in say Mg2P2O7, 2P you have to calculate, means 62 gram. Then give how much precipitate you got of Mg3P2. You calculate accordingly what I have I discussed previously. Then now here again you come to the ammonium phosphomolybdate. Generally, because this is a complicated question, will be asked only by this method. Then now again same way, let the mass of organic compound taken is equal to m gram, and mass of ammonium phosphomolybdate, that is the m1 gram. Then molar mass of ammonium phosphomolybdate is 1877. Remember, it will save your time in exam hall. Ammonium molybdate direct, if you will put the value and calculate, it will take some time. If you remember, because it is this type of compound is very less, it is exceptional. Then 181877, this is the technique I am telling you. Don't add all the things. You remember, then it will save your time. 1877 gram. Then in that phosphorus is how much? Phosphorus is only 31 gram. Only P is there. Then direct percentage of phosphorus you can calculate direct way. Now all things are you are knowing. Then you know that 1877 gram ammonium phosphomolybdate contains 31 gram. Then 1 gram how much? 31 divided by 1877. Then m1 gram. Suppose precipitate you got m1 gram. m1 gram, it was the phosphorus. Then precipitate was m1 gram. Then now just you multiply by m1. 1877 gram phosphomolybdate got contains 31 gram. Then 1 gram, then M1 gram, M1 gram. Then 31 into M1 divided by 1877. Now in percentage you want to calculate. Then compound you write down and 100 you write upside. Then this is the percentage, means 31 into M divided by 1877, upside 100 and down M you write into M. That is the percentage of phosphorus. Very easy way calculated. And if you are considering Mg2P2O7, second alternate method, then there also it will come 222 Mg2P2O7, that you can calculate. It is not very complicated. It will come 222. Magnesium, you know, magnesium 12 gram, phosphorus 31 gram, oxygen 16 gram. Hence it will come 222. And here P2 is there, and 62, 31 into 2, 62 gram contains. 222 gram Mg2P2O7 contains 62 gram phosphorus. Then 1 gram, 62 divided by 222. Then M1 gram, how much? Suppose you got this precipitate was Mg2P2O7, precipitate was M1 gram. Then just to multiply by M1 gram. And if you want to convert in percentage, then 100 you write upside, or mass of compound you write down. That is the M. And upside 100 means finally you can write 62 into M1 divided by 222, upside 100 down M. That is the percentage of phosphorus. And now I have discussed these things. Phosphorus also I have discussed. Now this oxygen, come to the oxygen. Oxygen is I think here oxygen you have to calculate in test, special test. I have not discussed oxygen test, but in estimation all things you will understand automatically. Oxygen, there are two ways you can calculate oxygen. Then how will you calculate this two ways? Then first way is easy. If all percentage you are knowing, other elements percentage, suppose you are knowing other percentage, oxygen you are not knowing, carbon you are knowing, hydrogen you are knowing, nitrogen you are knowing, phosphorus you are knowing, sulfur you are knowing. Correct? And other whatever we given, then total, from the total you can say only oxygen you are not knowing. Then if it is given 100%, then what is given, that you add, that you deduct from the 100 all, then what is remaining, that is the oxygen. Total, you add all percentage of given element, from that you minus it, for 100 minus this, then you will get difference will be of oxygen. This is a very easy way, but all they will not give, all percentage they will not give. Sometimes they can give, but always may not get. Hence other method that I am telling you. The percentage of oxygen in an organic compound is usually found by difference between the total percentage composition, means 100, and the sum of the percentage of all other elements. All other elements. Then now sum of the percentage of all other elements. Then oxygen can also be estimated directly as follow. Okay, I am telling you how to calculate. Now method. Now oxygen Just I will continue it in the other class. Now some important call has come. Thank you.